Let's take a look at your practice test. If we take a look at our first question here, don't forget your name. That's kind of important. And on question number 1, we have a centroid. Remember, a centroid is going to be the one that's in the ratio of 2 to 1 or 1/3 to 2/3. And we're looking for segment DB. So what do I know? Well, I know D to G is 5. That's 1/3 of that segment. So 2/3, G to B is going to be 10. So that makes D to B is going to be 15. Now, on question number 2, the important word here is orthocenter. Orthocenter means we're going to be dealing with the altitudes here. So remember, the altitude goes through the vertice and is at a right angle to the opposite side. It doesn't have to even go through the side, but it's got to be perpendicular. So what I'm going to do is I'm going to draw my altitude through G to start with. And you can do this algebraically or graphically. I'm going to suggest graphically, but I'm going to show you both. So we're going to start off here having it go through G. So I need to find the slope of EF. So I look at my slope of EF, and that's going to be -6 minus 4 all over 10 minus 2. -6 minus 4 is -10. 10 minus 2 is 8. So I know that slope is actually -5 over 4. So I want to go through G. So I'm going to say y minus or y plus 8 equals 4/5 times x plus 4. So we're going to graph that line. And I've already graphed my triangle, and I connected them so we can see it. So we said y plus 8 equals 4/5 times x plus 4. And you can see that goes through my vertice. That's at -4 and -8. And it's perpendicular to my opposite side. Okay, so that's the first part. So we got one altitude in. Let's do another one. Let's do the altitude through E. So that means we're going to find the slope of FG. So then I'm going to say slope of FG, that'd be -8 plus 6 all over -4 minus 10. -8 plus 6 is -2. -4 minus 10 is -14. That reduces to 1/7. So I know my perpendicular is going to be at -7. And I want to go through E. So I'm going to say y minus 4 equals -7 times x minus 2. So let's type that in. So y minus 4 equals negative 7 times x minus 2. And notice that goes through my vertices at 2 and 4. And then I can see there's my orthocenter where they cross. So 2.92 and negative 2.46. So 2.92 and negative, what did we say? 2.46. That's the way to do that graphically, and I think that's the best way to do it. To do it algebraically, I'm just going to solve that system. So I think it's easiest if we get y by itself in each equation. So in my first equation, y plus 8 equals 4/5 x plus 16 over 5. So then I'll minus 8 from both sides. So then I'll get y plus 8. Not y plus 8 because I already moved the 8 over. So y equals, we'll go 4/5 x. And then we minus 8. That's the same thing as minusing 40 over 5. So really, I'm taking 16 minus 40. And 16 minus 40 is negative 24 over 5. So minus 24 over 5. Now, in my blue equation that I did here, y minus 4 equals negative 7x plus 14. We'll add 4 to both sides. Y equals negative 7x plus 18. So now, to solve this equation, I'll replace y in one of the equations. So then I'll say negative 7x, come on you, plus 18 equals 4/5 x minus 24 over 5. Well, let's clear the fractions to make things easier. So you get negative 35x plus 18 times 5 is 90 equals 4x minus 24. Let's get all the x's on the same side, so we'll add 35x to both sides. At the same time, let's add 24 to both sides. So when I combine those, 90 plus 24 is 114 equals 39x. I'll divide both sides by 39. And notice 4, 5, 6, I can divide both of these by 3. Running out of room here, so x equals, and if I take 114 divided by 3, I get 38. 39 divided by 3 is 13. Now, I think I'll use my second equation. So y equals negative 7 times 38 over 13 plus 18. Well, negative 7 times 38 is negative 266 over 13. Might as well get my common denominator right away, so I'll take 18 times 13. And I get 234. Well, negative 266 plus 234 to be negative 32 over 13. And so my exact answer is 38 over 13, which is, like we said, about 2.92. And negative 32 over 13, which is about negative 2.46. Either way is a good answer. Like I said, I prefer the geometric way. That'll save you some time on the test, but if you don't like the geometric way, you can do it algebraically just as well.